Hello again, algebra students. In this mini lesson, we're going to be looking at how to add and subtract rational expressions. We're going to look at 4 examples of each of these. Now to start off with, we are asked to subtract these 2 rational expressions. Now as you look at the 2 expressions, you'll notice that each of them has a denominator of 12x. Now if I have 2 rational expressions or fractions that have the same denominator, it's pretty easy to add or subtract them. Similar to if I had, let's say, 2/3 minus 1/3. Because these 2 fractions have the same denominator, I can simply subtract the numerators, taking 2 minus 1, and writing it all over that common denominator of 3. Obviously, 2 minus 1 is 1, and 1/3 would be the final answer for that particular expression. The same principle applies here. Because I have a common denominator of 12x, I can simply subtract the 2 numerators. Meaning I can take 7x, my first numerator, minus the second numerator. Now when we're subtracting, we do have to be careful, especially if we're subtracting a polynomial, because we are really subtracting every term that makes up this particular polynomial. So I'm going to write it this way: 7x minus, in parentheses, 5x minus 2. I use the parentheses to remind myself that, hey, I'm not just subtracting the first term, but I'm subtracting each individual term that makes up that polynomial expression. Now, when we practiced subtracting polynomials a few months ago, one of the tricks that we learned was that we can distribute the negative sign and then combine like terms. So this expression will be rewritten: 7x minus 5x minus negative 2 really means we're going to be adding 2. Now all of this, if you remember, is written over our common denominator of 12x. I don't have to change the denominator, I don't add the 12s together, anything like that. I just leave it as 12x. Once I have it written this way, in the numerator I will combine any like terms that show up. So 7x minus 5x turns into 2x plus the constant 2 all over 12x. My last step here would be to try to simplify this expression if possible. Now, similar to if I had, let's say, 4/6 as a final answer to an expression, I wouldn't stop here. I would reduce this. I would say that 4 is the same as 2 times 2 and 6 is the same as 2 times 3, and I would be able to divide out or cancel a common factor of 2, leaving me with 2/3 as the final answer. The same rule applies here. At the moment, I can't cancel x's because this x is part of a sum and not a product. The same goes for the 2's. But if I were to rewrite the numerator as a product using factoring, so we'll write this as 2 times x plus 1. So I simply factor the 2 out of both of these terms. All divided by 12 times x. Now because my numerator and my denominator are both written as a product, I can factor out or cancel a common factor of 2, turning this into 1 times x plus 1, which I'll write as x plus 1, over 6 times x. This would be my final answer. Now for our second example, we have 2 expressions who do not have the same denominator. On the left I have a denominator of x plus 3, and on the right I have a denominator of x minus 5. In order to add these 2 expressions together, I have to find the least common denominator between the 2. Now to find the least common denominator, that means we're looking for the least common multiple of these 2 expressions. Sometimes it's as simple as multiplying the 2 expressions together. For instance, if I had to add the fractions 1/2 plus 1/3, the least common multiple of 2 and 3 would be 6, which would be the product of 2 and 3 multiplied together. So if I would add these 2 fractions, I would need to make each of them have a common denominator of 6. Well, to do that, I have to multiply the fraction on the left by 3 over 3, because I have a factor of 2 but not the factor of 3, and 2 times 3 is 6. So that would turn that expression into 3/6. I would have to turn the second fraction also into a number of 6. Well, to do that, I'm missing a factor of 2. So I multiply numerator and denominator both by 2, which gives me 2/6. I can then take 3/6 plus 2/6 and have 5/6. So the key is to find that least common denominator. If we were to use the same principle for the expression up above,